In this episode, we'll go step by step how PyTorch to design neural network in PyTorch. So I'll show you an equivalent task in Keras and in PyTorch side by side, so you can compare them. And then you get a feel, if you know how to do Keras, you can see how things look like in PyTorch, right? So first the libraries and Keras implementation. So I'll just do what we did long time ago of the default prediction. So you can see the Kaggle lone default prediction data that we did in earlier episode. So we'll keep the network really simple. So here first to import the libraries and then read the data. So we're gonna read it from the local drive. It's a tiny file. Default, which isn't in this Kaggle address. We saw it before. So first put it in df and then you convert to NumPy, isn't it? The values of, call it X, the employee bank balance and annual salary. We keep those columns and put it in X. And the defaulted indicator, the value, we'll put it in Y. So these are my X and Y variables. And then split into train and test data. We all did this before. We compute the mean and standard deviation of the training data and then scale the train and test data with it. Okay, so now build a neural network, the simple thing. So input dimension is the shape here, which has 3 columns. It goes to the hidden layer of 20, 10, and then eventually Y shape 1 is just 1. Okay, so we have a neural network that basically will do this. We use a binary cross entropy and we model fit. Okay, so there are 100 epochs, isn't it? 100 epochs. So let's have it train. Come back when it's done. Okay, it's done training. Let's evaluate it. So we use the model we had trained, predict the X test. We'll round it so that the Y prediction is 0 and 1. And it's correct when accuracy score comparison. It compares the Y prediction and the actual Y test and show how many of them are correct. So 97% correct, there are 32 faults. Okay. So how do we do this in PyTorch? So I commented out in text the equivalent Keras language. So it's similar to Keras in the importing the library. Here's the one that we did in Keras. Instead of TensorFlow, we'll import PyTorch. And then we'll read in the data, which is the same as Keras. So let's just quickly do that. Default frames, then under read, and then clean up the data, which is same as what we did with Keras. So I'm just going to standardize and all this. So now the new part, very new part. So how we do it? So Keras is simple, admittedly. We have a model called sequential. Add the dense layer, input shape 1 to 20, and then another layer to 10, and another layer, the output Y shape 1 it's actually size 1. You compile with the binary cross entropy and then fit the X train and Y train. So this is what we did in Keras. How do we do this in PyTorch? We typically define a class, like name it net. And most of the features there comes from prepackaged Google engineers developed NN module. So we borrow most of the features from module, but do a little bit of new. So the constructor. So the component of neural network. So we will have a layer of in to 20, another linear layer 20 to 10, and another linear 10 to out count. We haven't connected them yet. These are just Lego blocks that we are going to use. Okay, and a sigmoid. And so how do we use that? So here is actually, so here define forward and it takes X as an input. So the self of FC1, which is the into 20, and send that to our value function and then have it X. And the X then goes to self FC2, which is 20 node to 10 node middle layer. and then send it to a ReLU function after that. So, and call it again X, replace it with X, send it to self of linear, so 10 to output 1, okay? And then finally that X will send to a sigmoid. So this is how you do it. So this here is how these are just the Lego blocks of layers, but how they are connected, it's been actually explicitly done here in the forward path. It's defined here. And that is the definition of the neural network. So if you figure this out, then you're pretty much done. The rest is basically, we do have to use PyTorch tensor. So variable torch tensor of whatever variable you have and float. And then building the model is model equal net. Net is, this thing here is net. So we define a net of X shape here. Input shape and output shape is 1. Criteria is MSE loss, and we use an optimizer, Adam optimizer. Okay. So these are all what optimizer loss criteria will use on the model. You actually have to train it, which was one line in Keras like model.fit. Here we actually have a loop formally. So first set the gradients to 0 in the optimizer. Okay. And then the model X train out. So this is our network output. The network output is compared to the Y train and the criterion, okay? Criterion, remember, MSE loss. So according to the MSE loss, the loss is computed. So this is a function of many, many neural network things. Compute the gradient loss backward. And then step optimizer step is update the weights one step. And we do this for many epochs, okay? Basically 100 of them. That runs really fast. Now evaluating the performance is straightforward. Similar to what we did here, we have a model that uses X-test to predict. One thing you need to notice is that these tensors has to be detached to be used in an accuracy. So prediction of detached NumPy, Y-test of detached NumPy. So it detaches from the network and uses this value by themselves. I call it NP prediction, NPY test. Okay? So the accuracy is accuracy score, which we just borrowed this sklearn function of NPY test and NPY prediction. It gives us accuracy of 97%. Okay? So this is to show side by side how in Keras and in PyTorch neural network is implemented. Thank you for watching this episode.